We've reached the grand finale, learners. Welcome to the episode 19 of our NEET chemistry series for 2025 and 2026. I'm Chongthamdavid, your mentor, and with just 10 days left for NEET, it's all about the momentum, mastery, and mindset. In this final episode, we're diving into thermodynamics, the science of energy, work, and spontaneity. We'll tackle 45 exam crucial questions covering enthalpy, entropy, gives free energy, and everything NEET loves to challenge you with. But the journey doesn't stop here. From tomorrow, we begin daily full syllabus. Practice 45 questions a day until the exam to keep your revision sharp and focused. Here's something to carry with you in thermodynamics. Spontaneity depends on the right conditions. In life, success depends on the right effort at the right time, and your time is now. If this session helped you, don't keep it to yourself. Share it with your peers and help them power up their prep too. Let's finish strong, revise smart, and head into NEET with confidence. See you in the next phase. We're just getting started. Question number 1. In a closed, insulated containers, a liquid is stirred with a paddle to increase the temperature. Which of the following is not true? In an insulated system, no heat or matter is exchanged. So Q will be 0. Then your internal energy will be the work done. So the work done on the system increases the internal energy. So B is the answer for question number 1. Let's see question number 2. Of a non-ideal gas undergoes a change of state. The atmospheric pressure is 2.0 and the volume change from 3 liter to 5 liter. Temperature change from 95 to 245 Kelvin with a change in internal energy. Delta U equals to 30.0 liter atmosphere. The change in the enthalpy of the process in terms of liter atmosphere is. Now, enthalpy change can be written as delta H, which is the difference between H2 and H1. So applying the first law of thermodynamics, we can now impose this formula E1 plus P1 V1. Take the difference of these two, E2 minus E1, and add the pressure and volume P1 V1 to be subtracted from P2 P1 V1. So the difference in the internal energy, that is delta E or delta U, same thing. Now you got 30. What is the pressure given here? 2. So this would be 4 and 2 is for the pressure 1. So 4 into corresponding volume would be 5. 4 into 5 minus pressure 1 is 2 into 3. You have 44 liter atmosphere. So answer for question number 2, option C. I hope this is understood. Let us read question number 3. Assuming that water vapor is an ideal gas, the internal energy change when 1 mole of water is vaporized at 1 bar pressure and temperature 200 degrees Celsius. Given the molar enthalpy of vaporization of water at 1 bar, 373 Kelvin equals to 41 kilojoule per mole, and the ideal gas constant is 8.314 gas constant. and energy it is given. So what is the internal energy? So let us write this, substitute the values here using the first law of thermodynamics. Delta C, first law of thermodynamics can also be written in the form of internal energy as delta H minus change in gas moles, gas constant, and temperature. So enthalpy is 41,000 minus subtract this delta N is equals to 1. And you have to find only for gases moles. If you substitute for solid and liquid, that will be wrong. 373. So calculate the value. 41,000 minus so what will be the value of the multiplication of this 373 and 8.31? 4 3 is 12. Multiplied with 8.314. It is approximately 3101.122. So the difference between these two will be approximately 37,898.88 joule per mole. Divide by 1000 so as to get in terms of kilojoule per mole. Now you have 37.9. This will be in terms of kilojoule per mole. So the correct answer for question number 3 is option D. I hope this is clear and understood. Question number 4. A piston filled with 0.04 mole of an ideal gas expands reversibly from 50 ml to 375 ml at a constant temperature of 37 degrees Celsius. As it does so, it absorbs some heat, approximately 208 joule of heat. The values of Q and W for the process will be. You are given the values of log 7.5 and gas constant. Now, since the process is isothermal means temperature remains constant. So, since temperature is impacting internal energy, and we can also say this internal energy is a function of temperature. So at isothermal condition, the internal energy will be 0. The change in internal energy. So no internal energy is present. No change in internal energy is present. So delta 0 equal Q U equals to 0. Therefore, we can assume from the first law of thermodynamics that heat equals to minus W. So since the given heat is 208 joule, the work can be now expressed as negative of 208 joules. So answer for question number 4 is option A. Let us read question number 5. Among the following, the intensive property is, an intensive property is a physical quantity whose value does not depend on the amount of the substance for which it is measured. So question number 5, answer would be electromotive force. Because this electromotive force does not depend on the amount of the substance. The molar conductivity, resistance, heat capacity, these are all extensive. They depend upon the amount of substances. When I say substance, they are the state of matter. Coming to question number 6, the variation of heat of reaction with temperature is given by. This is given by an equation known as Kirchhoff's equation, which is basically the temperature and enthalpy relationship, del H2 minus del H1 divided by T2 minus T1, which is heat capacity at constant pressure. So this equation is known as Van Hoff. Sorry, it should not be Van Hoff, it should be Kirchhoff's equation. I hope this is clear. Question number 7. Let's read question number 7. The difference between the heats of reaction at constant pressure and volume for the reaction given. This is benzene, and oxidation gives carbon dioxide and water at room temperature in kilojoule is. So this heat capacity at constant volume is delta E. Remember this difference in the bomb calorimeter, heat is measured at constant volume. It refers to as internal energy. And if it is taken at constant pressure, isobaric, that heat is referred as enthalpy change. Now, according to the first law of thermodynamics, we can say delta E plus NGRT gives your enthalpy. Can I also rearrange this? Yes. Can now be written as delta NGRT. So where this delta NG represents the number of moles of gaseous products minus the number of moles of the gaseous reactants. So let us substitute the value here. We have got delta NG as 12 minus 15. We have to only check the gases products and the reactants. No need to check for the liquid because we are talking about the change in gas. The gas constant is 8.314 joule per Kelvin per mole, and the temperature is at room temperature, so 298 Kelvin, because by the conversion of 25 you can get from Celsius, you can get the value in Kelvin. The answer would be this is minus 3. You got a negative quantity here, 8.314, and temperature. So multiplied 8 3 is 24. 24 into 298 approximately. This would be, there is negative 0.314, so something like 7.4 kilojoule. So 7.4 minus option E is the answer for question number 7. Let's read question number 8. The enthalpy of vaporization of water from the following two equations is. So the desired equation, we have to build up. What is our mission? The target is to find the enthalpy. So desired equation is water changing from liquid to gas. We are asked to find the enthalpy change. So do one thing. Let us substitute these two equations, equation 1 and equation 2. Remember, this is considered as equation 1, this is 2. So when you substitute from this, subtract these two equations, this gets cancelled, hydrogen is cancelled, right? Oxygen also gets cancelled. And you will get the reversal of this. So by subtracting these two equations, you will be obtaining delta H equals 245.5 minus of 286, approximately 40.5. Option B, question number 8, is the answer. Question number 9, for complete combustion of ethanol, oxidation gives carbon dioxide, water, and energy. This amount of heat produced as measured in the bomb calorimeter is 1364 0.47 at room temperature. Assuming the ideality, the enthalpy of combustion. What is the enthalpy of combustion for the reaction? So according to this given reaction, the bomb calorimeter gives enthalpy internal energy as minus 1364.47 kilojoule per mole, and you have delta Ng as minus 1. So always remember, first law of thermodynamics questions are going to be expected from this law. Multiple times in NEET exam, questions are bound to ask from this first law of thermodynamics. So be prepared for that. Minus 1364.47. Since this gas constant is minus 1, sorry, this change in the gas mole is minus 1. I have taken the sign minus here. Not to get confused. Gas constant is 8.314. Temperature 298. Divide this by 1000. So do the simple math here. Subtract from this. By addition, this would give approximately here 0.298. So it would be approximately value would increase by a value of 2. So 1364 plus 2 would be approximately 1366.93. So answer is option A. Simple. Question number 10. The direct conversion of A to B is difficult. Hence, it is carried out by the following path. As shown, A to C, then D to B. You are given the change from A to C, C to D, and B to D, where EU is the entropy unit till unit. Then this change from A to B is how much? So let us apply the Hazel's law. Entropy depends upon the path. So path function A to C, then C to D, then we have B to D minus entropy change from B to D. Okay, let me write here at the bottom 50 plus 30 wherever applicable. Substitute the values, you get 60 EU, which is the unit of entropy. So answer would be A. Let us read question number 11. The heat of combustion of methane, carbon, hydrogen, etc. are given as 20 minus 40 minus 10. The heat of formation of methane is. So first of all, write the reaction. You know, any hydrocarbon on oxidation gives carbon dioxide, water, and energy. To balance here, I'm putting the coefficient 2. And the enthalpy is 20 kilocalorie. And carbon and oxygen treated to give carbon dioxide. The enthalpy would be given as minus 40. Let us say equation 1, 2, and followed by hydrogen oxidation gives water. Here write 2 to each. Then this enthalpy would be minus 20 So add these two equations and subtract. So we have carbon, hydrogen gives methane, right? So the enthalpy would be minus 20 plus minus 40 minus 20. It is now close to minus 40 kilocalorie. So the answer for this question number 11 is A. Got it? Moving on to question number 12. From the following bond energies, what is the enthalpy for the reaction? So enthalpy for the reaction can be calculated from this formula. Bond enthalpy of the reactant minus bond enthalpy of the product. So bond enthalpy of carbon-carbon double bond plus we have the number of bond here. How much? 1, 2, 3, 4. So I'm multiplying here with 4, not to get confused. Bond enthalpy of carbon and hydrogen plus bond enthalpy of hydrogen and hydrogen. This is for the reactant, okay? I'm going to enclose with a bracket to demarcate these two reactants and product. Then for product, you have bond enthalpy, carbon-carbon single bond. Let us do the counting. 1, 2, 3, 4, 5, 6. So carbon-hydrogen bond is 6. 6. Bond enthalpy of carbon-hydrogen. So substitute the values. You will be getting the total enthalpy change. 606.1. Okay, since there are 4 types of carbon-hydrogen bond, multiply this with 410.5 plus 431.37. This is for the reactant, okay, minus 336.49 plus 6 into 410.5. So calculate 4, 4, 16. 16 and another 413, 20, 26 minus 624, 27. So the value would be negative approximately 120. Answer would be option B. Let's move on to question number 13. The favorable conditions for spontaneous reactions are. So this is given by the spontaneity is decided by Gibbs, Meyer, and Helmholtz equation. Delta H minus T delta S. Okay, the one who gave the idea of thermodynamics, John Meyer and Gibbs. So this delta H okay, if this is endothermic, delta S would be also, if it is increasing in the entropy, you would be obtaining delta Ts is greater than delta H. This is forward process, the condition for spontaneous forward process. So this will make your delta G negative. So this is the answer. A would be the answer. Our condition, terms and condition is that delta G should be negative for a spontaneous process, for which change, enthalpy change, is not equal to delta E, that is entropy, internal energy change. So question number 14. you have to find from the first law of thermodynamics, which is related as delta N RT. This is R. So for delta H not equals to delta E, and the number of moles not equals to 0, where this delta N is the number of moles of gaseous products minus the number of moles of the reactants. So in this case, for this first option, let us check. Delta N is 2 minus 2 equal to 0. B, delta N is 0. And C, delta N is 1 minus 1, 0. And for this D, you have to only check for gas. Delta N equals to 2 minus 4 minus 2. So D is the answer for question number 14. Let us move on to question number 15. The species which by definition has 0 standard molar enthalpy of formation at room temperature is. So the species in its elemental form has 0 standard molar enthalpy of formation at 298 Kelvin. At 298 Kelvin, chlorine is gas, while bromine is liquid. So 15, answer would be option B. Moving on to question number 16. For which of the following process entropy is negative? So high the pressure, it reduces the volume. That means it decreases the entropy. So delta S would definitely be negative. So in this case, there is increase in the pressure. According to Boyle's law, it will be reduction in the volume correspond to the reduction in the entropy. 16b, 17. Let's read. Given the following entropy values in joule per Kelvin per mole at 298 Kelvin and 1 atmospheric pressure, hydrogen, chlorine. Okay. What is the entropy change in joule per Kelvin for the reaction hydrogen plus chlorine gives hydrochloric acid? So the entropy change delta S naught is 2 times for this particular reaction entropy for HCl minus entropy standard. Okay, this dot represents standard entropy of hydrogen plus standard entropy of chlorine. Let us multiply this. 186.7 minus. For hydrogen, you have 130.6 for chlorine. Okay, 8 into the 36, 360. 130 plus 223, approximately given 250, 350. So it would be a very small value, 19.8 joule per Kelvin per mole. So this would be the entropy change for the reaction, that is option D. Let us move on to question number 18. In the conversion of limestone to lime, the dissociation of limestone is given. The standard enthalpy change and entropy change are also given at room temperature at 1 bar. Assume they are standard, do not change with temperature, temperature above which conversion of limestone to lime, okay, this is lime, quick lime, will be spontaneous at what temperature? So this is a question. Spontaneous in the sense your Gibbs energy should be negative. So standard Gibbs energy is given by Gibbs-Helmholtz equation. Okay, this is the equation. So for a spontaneous reaction, delta G naught should be less than 0. Or your delta H minus T delta S should be less than 0. From this, what can we imply? The inequality gets shifted. Delta H naught by delta S naught. So we can say, okay, by substitution, temperature will be greater than 179.1 into 1000 divided by 160.2. Divide this 60 and 172, approximately 1000. So the value would be roughly 11 117.9. Okay. So 117.9 is rounded off to 118. Option A for question number 18. Clear? I hope this is understood. Let us read question number 19. The difference of enthalpy and entropy for the internal energy for the formation of carbon monoxide from its element at 298 Kelvin is. So for the reaction given to you here, carbon is formed by incomplete oxidation of carbon or coke. Okay, this is your gas. When this is, this forms unburned gas. This is neutral because the formal charge are all zero, as I have mentioned in the class. Delta U plus nRT. This is changed, okay? Now the difference delta H minus delta U is equal to delta nRT. Wait, this delta N equals to 1 minus half. So this would be half. So let us substitute here delta H equals minus delta U would be half 8.314 into 298. Substitute this value here. You're getting 238.78 roughly. So question number 19, answer would be option D. Clear? Move on to question number 20. The incorrect expression among the following is, which is not the correct expression. It would definitely be option C, because from the Gibbs equation, we know that delta G naught is delta H minus T delta S naught. Standard, okay? Anything with known quantity. Now, this is, let me substitute the value of equilibrium constant and relation between delta G, delta H minus. So from this simplify and you would be getting whether the answer is correct or not. So if I say I want to find this in terms, because the first system is correct, this is also correct, okay, from the work done expression and isothermal expansion, and this is also correct. Let us see whether this is the incorrect statement. So simply rearrange the term again, P delta S divided by minus RT, right? So this would become a negative quantity. So this is the wrong step. So C will be the answer. The incorrect statement is C. Let us see question number 21. From the two reactions, find the delta H value for the reaction given ferric oxide and reacting with carbon monoxide, reducing agent. It is removing all this oxygen. Reducing agents are the one which remove this oxygen gas. Now it undergoes reduction at question number 21. Let's read. From this equation number 1, let us name this as two equation entitled 1 and 2. Let us subtract these two equations. 1 minus 2. What would you be getting? You will be getting this equation. Subtract these two equations, you will be getting the ferric oxide undergoing reduction with carbon monoxide. When you substitute, the enthalpy change also gets affected. So take the difference between these two. The difference will become minus minus plus 33. It would be 6.2. 6.2 is the answer. So question number 21, A is the answer. Okay. Let's read question number 22. For a particular reversible reaction at temperature T, enthalpy H and S were found to be positive. And if T is the temperature at equilibrium, the reaction would be spontaneous. Interesting question. That's right. So at equilibrium, Gibbs free energy is always zero. There is no Gibbs free energy. It is zero. change in Gibbs free energy is 0. And the expression is again written as delta H minus. This is equilibrium temperature T delta S. This is for equilibrium process. Therefore, I can say delta H will be T delta S, and this TE equal to delta H minus divided by delta S. So for a spontaneous reaction, delta G must be negative, which is possible only if this delta H minus T delta S is less than 0, right? So the condition would be TE should be less than the temperature T. Equilibrium temperature cannot be greater. Question number 23. The standard enthalpy of formation of ammonia by Bose-Haber process is minus 46. If the enthalpy of formation of hydrogen from its atom is 436 minus, and that of nitrogen is 712 Kelvin, kilojoule per mole, the average bond enthalpy of hydrogen bond in ammonia is. So let us write the general reaction from Bose-Haber process. This is an industrial method for preparation of ammonia in large scale, pungent gas. So since there are 2 mole, we need to multiply this with 2 into minus 46. In some books, you will be finding only 46, that is in terms of, that is for only 1 mole. Since you are obtaining 2 mole, this will be in terms of, you have to write here kilojoule. Okay, so if let us consider the bond enthalpy of nitrogen hydrogen bond be X, and remember enthalpy of formation or bond formation enthalpy is given, which is negative, but the given reaction involves bond breaking, hence value should be taken as positive. So whenever bond breaking, endothermic bond making, exothermic, the basic rule of the thumb, right? Enthalpy change will be the sum. Okay, let us take the overall bond energies of the reactant minus the bond energy of the product. So basically this would be 2 into minus 46, and for reactants 712 plus 3 into 436 minus 6 times of X. Because you have 6 nitrogen hydrogen bond, right? 6X. Okay, let us rewrite, calculate at the bottom. 292, yes, minus 92, 2020 minus 6X. 6X would be 2112. So from this, X would be 352. Answer is option B. Clear. Let us read question number 24. Standard entropy of X2, Y2 and X, Y3 are 60, 40, and 50 for the reaction. To be at equilibrium, the temperature will be. So for a reaction to be at equilibrium, the delta G should be equal to 0. So since Gibbs free energy can be calculated from Gibbs-Helmholtz equation, let us learn to write the equation here. Delta G is delta H minus T delta S. So at equilibrium, delta H minus T delta S equal to 0. So what can we get from this equation? T delta S. Fine. So for this reaction given here, we have encircled. Delta H is already given to be minus 30 kilojoules. This is the given. So let us do the calculation for finding entropy change for the above reaction. Entropy change delta S is equal to 50 minus half 60 plus 3 by 2 into 40. So entropy unit is joule per Kelvin. Let us substitute the equation here. 50 minus 30 plus 60. This would be 40. So at equilibrium, the product D delta S is equals to enthalpy. Why? Delta G is 0, right? So substitute the values. You are obtaining T minus 40 equals minus 30 into 1000. Because 1 kilojoule equals to 1000 joule. And now you can easily get the value of T here. So minus 30 into 1000 divided by minus 40. Cancel the minus and 0, 425. So answer would be 750 Kelvin. So C is the answer to this question number 24. Let us read question number 25. A heat engine absorbs, okay, the spelling is incorrect, absorb. Heat Q1 at temperature T1 and heat Q2 at temperature T2. Work done by the engine is Q1 plus Q2. This data violates, let us note one by one. According to the first law of thermodynamics, energy can neither be created nor destroyed, although it can be converted from one form to another. Okay, this is the general law of the first law of thermodynamics, which everyone knows. And you should know that the Carnot cycle is based upon this principle, but during the conversion of heat into work, some mechanical machine work is always converted to other form of energy. And hence, this data violates the first law of thermodynamics. So we can say option A is the incorrect statement. Next, moving on to question number 26. The standard enthalpies of formation of carbon dioxide, water, and glucose are minus 400, 300, 1300 kilojoule per mole, respectively, subsequently. The standard enthalpy of combustion of glucose, okay, per gram of glucose at room temperature, that is 25 degrees Celsius. So why don't we write down the reaction first and explain this? To explain this question, we need to write a thermochemical equation. Oxygen, as I have told, the product would always be water and carbon dioxide along with some energy. To balance this, okay, first of all, remember don't forget to write the state of matter. This is very crucial. Right. To balance, we have to put here 6 here, 6, and water 6. Good. What is the enthalpy for combustion of this reaction? We can calculate 6 into enthalpy of formation of carbon dioxide plus 6 into enthalpy of formation of water molecule minus enthalpy of formation of, this is for reactant, this is for glucose, C6H12O6. So this would be 6 minus 400 plus 6 minus 300 and minus 1300. So minus quantity 2900 would be the answer. Anyway, this is not the answer yet. We have to find the enthalpy change for 1 gram. For 1 gram of glucose contains, divide this by the atomic mass. Molar mass of glucose is 180. So minus 16 approximately. Answer would be option C. C is the answer to question number 26. Let's see question number 27. Using the data provided, calculate the multiple bond energy of a carbon-carbon triple bond in ethane. That energy is, okay, you have to find the energy for this reaction. So let us name this as equation number 1, equation number 2, equation number 3. So from equation 1, we can obtain 225, right? This value, 225, is equals to 2 times enthalpy for changing the solid carbon to gaseous carbon, plus 1 time bond enthalpy for hydrogen and hydrogen, minus 2 into bond enthalpy of carbon hydrogen bond, plus 1 into bond enthalpy of carbon carbon triple bond. So 225, 1410, 1 into 330. So 2 into 350 plus 1 into bond enthalpy for carbon carbon triple bond. It will be 225, 1410, 330 minus, subtract this, 700 plus bond enthalpy of carbon carbon triple bond. So from this we can obtain the value easily now. 200, 1740 minus 700, calculated, bond enthalpy carbon carbon triple bond, right? Okay, so we are about to determine BEC. Bond enthalpy of carbon carbon triple bond will be now equals to 815. So answer for this question is D. Clear? Let's read question number 28. Moving on to the next question. The options are given in the next slide. The enthalpy of neutralization of ammonium hydroxide, a weak base, and weak acid, weak base is 10.5 minus kilocalorie per mole. The enthalpy of neutralization of acetic acid with strong base 0.12, 0.5 kilocalorie per mole. The enthalpy of ionization of ammonium hydroxide will be. So for this question, okay, let us define this enthalpy of neutralization. Let me represent here N, which simply means enthalpy of neutralization. This is for strong base and strong acid. Given minus 30.7. And the enthalpy of ionization of acetic acid. Minus 12.5 minus 13.7. This will be 1.2 kilocalorie per mole. Okay, let me write at the bottom. Delta H ionization for ammonium hydroxide as per the question. You have minus 10.5 minus 13.7 as given in the question. Okay. Delta H ionization for this acetic acid. So this would be 13.7 minus 10.5. And also subtract this value, that is how much it was given, 1.2, which we have already calculated here, right? So obtain the value 10, 1.2, 12, 11.2. It should be 2 calorie approximately. So for question number 28, option B is the answer. Let's read question number 29. The enthalpy change of formation of carbon dioxide is 393 minus, and that of water is minus 286. The enthalpy of combustion of 1 mole of ethanol is minus 1360. The enthalpy change for the formation of 1 mole of ethanol from its constituent elements is. So we shall write the proper chemical reaction for this first. Graphite, as you know, is an allotrope of carbon. There are 3 allotropes, main allotropes. If this undergo oxidation completely, it gives an acidic oxide. Carbon dioxide is acidic. Now minus 393 Kelvin, kilojoule per mole. This is the enthalpy of formation. Now for hydrogen gas reacting with oxygen to form water, the given enthalpy is, according to the question, minus 286, right? Given here 286 kilojoule. Let me name this as equation number 1 and this as equation number 2. Right. And one more equation is to be written here, that is for ethanol. You know, ethanol also undergo oxidation to give carbon dioxide and water, and energy delta H is minus 1360. To balance this, put here 3, 2, and 3. Let us say this is equation number 3. So the enthalpy of formation of 1 mole of ethanol, to find this, let us do manipulations. Multiply this equation number 1 by 2 and equation number 3 by 2 by 3 and subtract from this equation number 3. So to demarcate this, within the bracket ones are the equation, and simply multiply 1 by 2, 2 by 3 and 3 by 1 so as to get the desired equation, this equation. Reverse it and you will be obtaining the enthalpy change for the formation of 1 mole of ethanol. And this is for the combustion. So after, okay, let us change this color so as to make it more distinctive. So we shall be getting a reaction after operation of this given half oxygen gives your ethanol. This will be the formation of 1 mole of ethanol. After undergoing this operation, we will be getting this equation. Now, for the heat part, multiply 393 as given in the question. For hydrogen, you have minus 286. Then again subtract 1360 because you are transposing on the right side. Minus 248. So after calculation of this, you will be getting this value. So minus 248 is the answer for question number 29. Let us see question number 30. Lattice energy of solid sodium chloride is 180 and enthalpy of solution is 1 kilocalorie per mole. The hydration energies of sodium and chloride ions are in the ratio 1:3:2. What is the enthalpy of hydration of sodium ion? So hydration enthalpy can be calculated as such. Enthalpy of solution minus enthalpy of lattice in a crystal lattice. So what you have here is 1 minus 180 as given in the question, 1 and minus. So this will correspond to minus 179 kilocalorie. So the enthalpy of hydration of sodium ion and chloride ion respectively will become minus 179. Right. So we can say that this enthalpy of hydration of this sodium ion plus 2 by 3rd of enthalpy of hydration of this sodium ion, because this is in the ratio of 3:2, would be minus 179. So take the LCM and find the enthalpy of hydration of sodium ion. 326. Divide this by 6 by 4, 6 by 3, 2. 179 divided by 2 would be no 2, it will be 5 by 2. Okay, so it will be minus 107, approximately 107.4. It is a negative quantity, so not to get confused, it would be option A. Here also it's given 107.4. Here also 107, but the difference is in the sign. Okay, so option A will be the answer for question 30. Let us read question number 31. A certain reaction is non-spontaneous. The entropy change during the reaction is 121. The reaction is endothermic or exothermic. The minimum enthalpy for the reaction is. Easy question. So for non-spontaneous reaction, Gibbs energy will be positive, and according to Gibbs-Helmholtz equation, if the entropy is 121 kilojoule per mole, we can say that the Gibbs energy will be positive, and delta I should be positive, and the reaction is going to be endothermic. And the minimum value of this enthalpy change can be obtained by putting that delta G is equal to 0. So we can say that delta H is T delta S. So 298 Kelvin is the temperature. And multiply this, you'll be getting approximately 1003,606. Right, so divide by 1000 just to get in terms of kilojoule per mole. So the answer would be, it is endothermic, to be a spontaneity. Question number 31, answer option A. 32, which of the following statement is incorrect? Okay, the standard enthalpy of a reaction is changed for the reaction when all the participating substances are in the standard states. Correct. The standard state of a substance at a specified temperature is its pure form. Correct. The standard solid iron at its pure form at 1 bar. This is wrong because the standard enthalpy of reaction is the enthalpy change for the reaction when all the participating substances are in the standard states. The standard state of a substance at a specific temperature is its pure form at 1 bar. And for example, let us say the standard state of liquid ethanol at 298 Kelvin is pure liquid at 1 bar pressure. That differs with respect to their boiling point. And the standard state of solid iron at 500 Kelvin is pure iron at 1 bar. So C cannot be the correct answer, and hence it will be the answer for question 32. Let us match this column. Question number 33. It's easy. A, delta H should be negative, exothermic, right? B, negative spontaneous process. C, cyclic process, equilibrium, delta G. So if A3, B4, C1, D2, D will be the answer for this question. 34, the enthalpy at 358 Kelvin is given, and Cp for ferric oxide and hydrogen are also given. So we are required to find delta H. So using the Kirchhoff's equation, we can say delta H2 minus delta H1 divided by T2 minus T1 equals to delta Cp. This is at constant pressure. So delta H2 minus 33290 by 358 minus room temperature 85.9. Right? So delta H would be minus 281.136. Use the Kirchhoff's equation and calculate the answer. Easy. Let us do question number 35. The enthalpy of neutralization of uric acid in 1 molar solution with a strong base is 56 kilocalorie per mole. If the enthalpy of ionization of acid is 1.5 kilocalorie per mole, and enthalpy of neutralization of the strong acid with a strong base is minus 57.3 kilojoule per equivalent, what is this percentage ionization of the uric acid in molar solution? Assume the acid is monobasic. So the percentage ionization in 1 molar solution would be 1.5 minus 1.2. Simply use the formula and you can answer this. you will be getting 0.330 by 1.5 would be 20. Question number 36. Delta H standard enthalpy of formation of NF3 is minus 113 kilojoule per mole. And bond energy is given for NF. And if nitrogen and fluorine bond energies are in the ratio of 6:1, their magnitude will be. So question number 36. Let us say the bond energy of nitrogen is 6x. Fluorine and NF3. And for this, enthalpy is minus 113. So can we multiply this equation by 6x 3 by 2 x 273. This will be minus 113 kilojoule. On solve x, you'll be getting the answer for this. 2, 3 plus 3, it will be 9, 14, 1 in hand, 5, 7, 7, 9, 7, 4, 9, minus transpose on this side. Subtract again, you will be obtaining approximately 500, 3x. So x would be approximately minus, will become plus 156.9. Multiply this again with 6 times because we have considered 6x. So 941.4. D will be the answer for this question. Question number 37. Consider the following process. For B plus D giving E plus 2C, delta H will be. So to calculate this, let us say this is equation 1, equation number 2, equation number 3. So to calculate this enthalpy change, let us multiply equation number 1 by 2, and equation number 2 is added, and subtract equation number 3. So let me write here, delta H will be 300 minus 125 minus 250, minus 175. B is the answer for question 37. 38, for isothermal reversible expansion, this is theory based. The value of Q can be calculated by the expression of, it will be A. Question number 39, match the column. So these are the options. So this will be A, B, D4. Okay. So A3, B1, C2, D4. Right? A3, B1, I've done a mistake here. Wrongly matches between C and B. A3, next this enthalpy of atomization. B1, C2, D4. So this means option C. A3B1C2D4. A3B1C2D4. Okay, let's do question number 40. From the following data of the following reaction, calculate the composition of the mixture of steam and oxygen on passing coke at 1273 Kelvin, keeping the temperature constant. So the first reaction is exothermic and the second reaction is endothermic. On passing the mixture of oxygen and water over coke while keeping the temperature constant, this enthalpy of both the reaction must be same, and moles of oxygen negative of 132 kilojoule will be, okay, let's do the calculation here. 0.5 into 132 by 110. Cancel this. Half would be 55, approximately 0.6. So the ratio must be 1:0.6. Where is 1:? Okay. A, option 1. 40 will be option A. The heats of neutralization of acetic acid, formic acid, hydrogen cyanide, and hydrogen sulfide are given as in terms of calorie per kg equivalent, arranged as such an increasing order of the strengths. So the greater the negative of heat of neutralization, more is the acidic strength. So do the comparison from this data. So the first would be formic, acetic. Okay, since it has the formic acid has the highest, followed by acetic acid, then your hydrogen sulfide, then hydrogen cyanide. Do the comparison, more negative, more is the acid strength. That is the key in Kirchhoff's equation. Which of the following salts should cause maximum cooling when 1 mole of it is dissolved in the same volume of water? Okay. You are given sodium chloride, potassium nitrate, potassium hydroxide, and bromide. So dissolution of potassium nitrate is endothermic. So heat is going to be absorbed and cooling is observed. So B is the answer for question number 43. 42. 43. Read the following statements carefully and choose the correct option. Correct option, right? So question number 43. Internal energy of the system is a state function. Good, correct. Work done, so work is done on the system. Wrong. Anything done on the system should be positive. Work is done by the system. Incorrect. So only one is correct. D is the answer. Let us read question number 44. Easy question again. Consider the following reaction occurring in an automobile. Okay, this is your octane gas. Octane and oxidation gives carbon dioxide, water, and lots of heat. The enthalpy, entropy, and delta G would be. So this is a combustion reaction, and in combustion reaction, exothermic reaction is always bound to take place. So either B or C, not B and D. So let's rule out these two options. Now let us focus on our priority, B or C. Okay, that is for enthalpy part. As the number of these gaseous molecules are increasing, entropy should increase. So positives by far, both are same. Now we are left with and Gibbs energy. So for a spontaneous reaction, Gibbs energy should be negative. So option B is the correct answer. So after clearing all this, you can verify that B is the answer for question number 44. Now, as usual, you solve this last question and try to give the answer in the comment section. Thank you for joining up to the end. We shall meet in the following episodes where there will be a miscellaneous question for all the syllabus. See you in the next episode.